Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We've got a great webinar on tap today, lots of fun stuff going on. But before we get started, we do have a few housekeeping items to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we send email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for any of our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar is a drawing for 3 $50 Amazon gift cards. So please stick around, hopefully you'll be one of our big winners. Okay, with that, we will kick off today's webinar, which is top 5 enterprise must-haves for Kubernetes DevOps in 2020. Our speakers today are Eva Tuksai, who is Engagement Manager with the Advanced Solutions Product Management at Turbonomic, Asena Hertz, who's Product Marketing Director at Turbonomic, and Dan Jungst, who is Senior Principal Technology Evangelist at Red Hat. Welcome. Thanks for joining me today.
Thanks, Charlene.
You're
thank
welcome.
you.
Yes. So, Asena, I think you are going to be starting the conversation, so I'm just going to put myself on mute, let you get right to it.
All right, thanks so much. And just one housekeeping thing from Red Hat and Turbonomic. Just wanted to give a shout out. We're doing a 2020 State of Multi-Cloud survey and report. We started this back in 2019, so really looking to see how things have changed over the last year. So we'll be reaching out to you folks via email and sending out the survey link for that. Would really appreciate it if you could take it and share your insights, and we'll get some really cool data and trends from that, which we will put together in a report and share out. So, all right. So yeah. You're here, top 5 enterprise must-haves for Kubernetes DevOps. We're going to give it all away in one slide. 1, collaboration. 2, containers and microservices, or a plan to get there. 3, continuous performance. 4, operations built for and to scale. And then 5, business stakeholder feedback. So this is both what you will be learning about today, our agenda. We're just going to kind of walk through this, keep it pretty casual, and again, ask any questions throughout. We'd be happy to answer them. So starting off, collaboration and cultural buy-in. Just wanted to share some data here from a different survey that we did, and obviously we asked the question, what's the biggest challenge to your organizations? This was specific to assuring application performance, but yeah, broadly, collaboration in terms of DevOps is a key thing, and it came in second here. And one of we asked also kind of guidance from the respondents to share with their peers. So I wanted to share a quote from that. Collaboration and people skills, dealing with various upper management and department heads. It's a tall task to get everyone on the same page. And being able to make calculated compromises, I've had to do it many times to get the projects up and running to positive results. So it's a really big challenge for folks, and I think for those of you on the line, this should come as no surprise. And I guess before we get into a specific example that we wanted to share with you all, Eva, Dan, did you guys want to add anything at this point?
Yeah, I'll jump in. So, at Red Hat, we deal with a lot of very large and small and medium-sized organizations, enterprises, businesses, government agencies. And many of them, in fact, almost all of them are trying to figure out how to transform their organization, their business, to try to achieve better results. So they're looking at digital transformation, and they're looking at DevOps as one way to help do that, right? How to really accelerate the delivery of applications through DevOps. But DevOps, as we'll talk about today, is a very intricate thing, and it involves a lot of collaboration, as you say here. One of the challenges that we hear our customers talk about is the fact that you really do need to get cultural buy-in. You need to get the whole culture on board to do DevOps, because it's really a fundamental change in the way that you approach doing application development and testing and delivery and running in production, right? It's a completely different way to do things. So you need to have all the teams bought into it and committing to it, to making this cultural change. And so it's definitely, the data validates it here, but it's definitely very true from the customers that I talk to out in the field.
Great. And we did want to just give one example, kind of how it plays out in the real world, and this is based on some of the customers that we've talked to here. So Eva, if you want to just kind of walk us through what's going on over here.
Sure, and this is kind of an example of, even if you have the discipline that Dan talked about and created these roles, if you're not collaborating, you're basically all in isolated silos along this pipeline, right? So let's assume we have deployed our first microservice, so we're getting our feet wet here, and the developer is sitting there saying, okay, I'm responsible for sizing this particular service, and because it's got to deploy in this multi-tenant cluster, and I'm going to give it a value, maybe take some testing data, but I'm going to, with all due respect, maybe just give it enough, high enough, and kind of toss it over the fence, right? So now over the fence it goes, and this is running in production. It's running live, and the site recovery engineer, or maybe even there's a hybrid DevOps role here, they're looking at behind them and saying, okay, wow, this is the first service, but there's a lot of people lining up here. How am I going to predict how much capacity that they need? How am I going to predict how much they're going to use? And how will I know if I can onboard more applications and services, right? I just don't know how to predict all of this because I'm not privy to this whole sizing exercise. And now we've got maybe a user tester. This could be a UAT environment. They're actually saying, wait, something's not working. It's not working well. I thought Kubernetes solved everything. I thought OpenShift solved everything. And then they start to realize, how do I actually assure performance? And now the infrastructure engineer is saying, wait, you guys are asking the question about performance. You think you need more resources. You're either maybe not as utilized as you thought you were, or guys, you're spending too much. There's no such thing as serverless. Someone's paying that bill, right? So the ultimately, someone has to make that decision going, okay, these services, I'm going to use my canary or blue-green strategy, and I'm going to roll this back until someone figures out exactly what's going on. Is it the code or is it the node? And there's a line of business who's sponsoring all of this, basically saying, I think we're having some, Houston, there's some problems. And the CIO, our pointy-haired manager, is going, I thought this was all supposed to just help my business.
Yeah. So just again, just one example of how important the communication and not having these silos can be when it comes to DevOps. And as Dan was touching on earlier, like cultural buy-in is really, really important. There's a lot of facets to getting that collaboration going, but one of the important things is getting a platform that unifies these teams and can really offer value, one platform that can offer value to the different audiences and the different use cases that each of those teams that you saw earlier, they're all involved in the whole process. So I guess with that, Dan, do you want to kind of walk us through what's this view?
Yeah, so Red Hat's OpenShift platform is our enterprise Kubernetes application platform. So it's built on Kubernetes. Red Hat has been one of the early players of Kubernetes for the past 5 years or so, and one of the top contributors today. But what we realize, we've been working with enterprise customers and developers for years, and we know that they need kind of more than just container management, right? So OpenShift layers on top of Kubernetes a bunch of technologies that you need in order to really build an application platform that you can use to develop applications and then also test them and deploy them and run them. And so we've got tooling for the developers. They have access to be able to do their own self-service provisioning, in the environments that they choose, using the middleware technologies and the language runtimes that they want. And then they can do everything and have automated CI/CD pipelines for doing full deployment. And then the management tooling as well that comes with OpenShift. From an operations standpoint, OpenShift, especially our version 4, we just announced version 4.3 is available, but it has a lot of kind of automated capabilities for operations. So it has multi-tenant capabilities. It has automated operations with OpenShift operators. It has over-the-air updates for the whole platform itself. So all of this gives both operators and the developers, a consistent and common platform to work in for building and deploying applications. And so, having that consistent platform, having kind of shared dashboards and shared views makes it much easier for these teams to collaborate and work in, kind of DevOps and agile approach, using DevOps teams and or DevSecOps, as well, bringing in the security guys. So having a platform like this just makes that so much easier.
Yeah, and then Dan, on top of that, then you've provided this fantastic foundation that starts that collaboration because you provide this common platform. Turbonomic then starts to ask the question, when you're running in your dev, test, and production environment, what kind of information, and more importantly, what kind of decisions can be made to help take care of the challenges of application resource management? Because even though the paradigm is, these are containers, they're ephemeral, don't get emotionally attached, you still need to assure the performance of these services, and there's still a relationship in being able to manage resources of now what's clearly a lot more complex environment, because you went from one monolithic platform to 12, 20, or 150 services. So Turbonomic fits into this platform because we provide this unique full stack view of the OpenShift control plane, the OpenShift services running there, the cluster, and stitch it together with your choice of underlying operating infrastructure. And we provide visibility and data and actions that can take to manage each one of those layers in the stack. And this information can get fed back into these areas that OpenShift is helping provide a common platform to.
Great, and we'll talk a little bit more about continuous performance, as that was number 3. So moving on to number 2, we've talked about obviously collaboration, cultural buy-in. That's first and foremost, I think, because that's really about laying that foundation. But you do also need the technologies to make DevOps, the vision of DevOps truly possible, right? So what we've highlighted here is microservices, right? Loosely coupled services. They have fewer dependencies. You can do iterative development. There's less risk with deployments. And then Kubernetes came along, and you have you can run all of that elastically and at scale. And all of these pieces have really come together. Again, highlighting people, process, cultural buy-in, coming together to achieve that dream of DevOps that's actually been around for quite a long time. So increasing throughput and faster innovation. So we're going to talk about you do really need to modernize your apps in order to automate things. You need to automate in order to move quickly. And we've got some more data for you here. Again, from that same survey, we asked how are people modernizing their applications or planning to modernize. And we found that while 2/3 of organizations are modernizing or planning to modernize, only 24% are refactoring. So the other options here, the text is a little small for those of you in the audience. Their replatforming is an option, rehosting, retiring, and retaining, making no change at all. and then refactoring, and then lastly, repurchasing. So SaaS offerings and the like. So we just, pointing out the 24% for refactoring, because that's really where you're going to get the most benefits for DevOps, but it's hard. And I know, Eva, if you want to just share a little bit about Turbonomic, we've gone through this application modernization process, and it's taken, it's been a journey.
It's been a journey, and just like Dan says, it has to start with having the right culture and mindset, the commitment. It took us over 2 years to take our monolithic platform and turn it into microservices. But I also want to bring it back to Dan too, to share his experiences. We've seen our customers think that to get the benefit of microservices, faster time to market, agility, elasticity, that they have to do this stepwise approach. Refactoring legacy applications is work. Sometimes it's better to start with something brand new that you don't have the classic luggage to bring along with you. But sometimes people that think that they have to first go to the cloud to get a taste of elasticity. And that doesn't always pan out, because you're basically just taking the same application, you're just putting it on different infrastructure. It's still the same application. Dan, do you want to share some of your insights, since you're really kind of an enabler to get people to that refactor stage?
Yeah, there's a couple of interesting points here, and I think you're right on. One is just going back to containers and microservices. Why are they necessary? And that some people may say, well, I can do DevOps without containers, right? And you can, but the cool thing about containers is they just make it so much easier to automate everything, right? And the key part of DevOps, one of the fundamental tenets of DevOps, is to automate as much as you can. Automate your builds, and automate your testing, and automate your deployment. And with containers, because the way containers are designed, they have an image layering aspect, so that the definition of what's in the container is something that's created by layers of the image definition. And so because of that, it's very easy to script or automate kind of how that's controlled. And that also makes them portable, so you can very easily move them from dev to test to prod. So that's just going back to why containers and microservices is because they do actually make it easier to do this automation and to do DevOps. In terms of like replatforming and rehosting and refactoring, ultimately you're going to get the benefits of a true cloud native application if you refactor, and those benefits are things like elasticity and scalability, as well as reliability, right? A cloud native application may have multiple copies of a microservice running, and if one dies, then the application will keep running, just as a very simple example. And so there's reliability aspects, reasons for wanting to do cloud native. You can, as Eva said, you can make a stepwise incremental journey to getting there. And one way is to move applications to the cloud in VMs. Another way is to actually move some of your applications, if you have stateful applications that you're running in your classic environment, if you will. Those stateful applications can also run in containers on OpenShift, because OpenShift has persistent storage available as part of Kubernetes. Then you can actually run stateful applications in a container as the first step, and before moving it into a completely refactored application, which may be running in 10 containers or more. And so you can kind of take the stepwise approach, and some customers are doing that. Some customers are going all in, trying to rebuild everything, but there are certain applications where it may not make sense to refactor and rebuild it. And so you may want to just consider running it in a kind of rehosted or replatformed way.
Yeah, I think that's a good point, Dan, is that you shouldn't shy away from statefulness, right? In terms of picking out your candidate, your poster children, to show the success of leveraging the speed and agility and elasticity of something like containerization and the OpenShift platform. You're right, not everything has to be stateless, but it's just as important to get that notion of these roles, the collaboration, and that CI/CD pipeline built is just as important in parallel rather than, you know, exactly what services that you're containerizing, right?
Exactly.
All right, so on to number 3. I guess we've talked about, you know, just talking about the value of microservices. The flip side of that, of course, is that it does create a lot of complexity. And at the end of the day, you can't reliably increase throughput if your services don't perform. So what we're showing here is just, you know, a simple microservice application, whereas, you know, this is the modern application. In the past, as Eva kind of touched on earlier, monolithic applications had their single application stack, which you guys can see here. That's, you know, providing those resources to the application, making sure that it performs. Now you've got that on a much grander scale where it's not just a single application, but many services of an application, each of them having their own application stack. And if there's congestion at any one of those points, you run into performance issues. So this is where Turbonomic actually comes into play. What Turbonomic is doing is making the right resource decisions for every layer of the stack. What we're highlighting here, again, because it's Kubernetes, is Kubernetes specific decisions that the software is able to make. Again, making decisions like how should you size your containers? Eva touched on that earlier. When do you need to reschedule pods? So move pods, redistribute load, and to which node? And then when do you need to scale out or back the cluster by how much? So this is Turbonomic's core value, looking at application demand, those resource demands from the service, and then making all of these decisions at every layer of the stack to ensure that that service gets those resources that it needs to perform. And again, these actions we're highlighting here, they can be automated, and they really should be automated. To Dan's point earlier, you know, one of the key tenets of DevOps is to automate things. So this is where Turbonomic can help a lot, just for that performance assurance, no rollbacks, what have you.
And this is a little bit more than just monitoring and thresholding. I mean, clearly in the community, in the landscape, there are observability tools. But if you just tracked memory CPU usage and picked a threshold, you're not assured that the action is even actionable. Turbonomic's analysis of this entire supply chain is that when we look at either a service is nearing its limit, and let's face it, there are certain things that are not able to really be scheduled beyond the limit. Out of memory is a great example. Don't wait for a service to be congested. Understand where you need to add more. Understand where you've over allocated requests because you didn't know what the service actually need to have guaranteed. But then we understand in our analysis whether the underlying infrastructure, the cluster, can actually provide additional resources, whether other services competing for those same resources are using them or not. Now, these are actionable because we can leverage the interface with core Kubernetes. That's why we're compliant with all upstream Kubernetes. We can also make other decisions, like if I can't resize something, I'm not going to say resize something if the underlying infrastructure doesn't have it. I have other actions that will occur. I will redistribute pods in the cluster. Kubernetes never asked the question where a pod lands is at the best place for it to stay. We make those resource decisions before something gets evicted, before there's a congestion. And ultimately, we may say you need to scale out the node. And we can leverage the OpenShift machine operator as an example. Because we're right there in the OpenShift cluster, we can take advantage of these great capabilities in OpenShift 4 and not only have the brains to know when to scale out a node, we know which one should clone, and we can tell the machine operator to go do it. And I think that's a great story. And then ultimately, if this is running on, let's say, VMware, I can actually even assess if the ESX cluster has the capacity to even accommodate that other node. And that's the full stack story that can be collaborated across everyone infrastructure, DevOps, and even application people.
Yeah.
Yeah.
And just to add to that, oh, sorry, Dan, go ahead.
Yeah, I was just going to jump in. So I love this. Actually, before coming to Red Hat, I worked in the application performance management space for a number of years. And one of the things we used to say is to measure is to know, right? You got to have visibility into things in order to understand what's going on, how they're performing, and how to fix things when they break. And so, Red Hat with OpenShift, we have some capabilities around monitoring and kind of operational stuff. But we also fully support partners like Turbonomic, who actually double click and go into the next layer and provide like detailed analytics and measurement and also being able to tweak things via the APIs that we expose and via the APIs that Kubernetes exposes. So it's really important, I think, for our customers and attendees to understand that, measuring and monitoring and doing even the next step of operations management is super, super important, right? You can't discount that. You can't just assume that you're going to be able to find it. You need to look at all the capabilities that you have to bear in terms of tools like Turbonomic as well. And so I think it's super important.
Exactly, and just wanted to end on the note that we were highlighting continuous performance here, but as you guys have been touching on, really, when you have software making these resource decisions and working with those mechanisms and scaling out those nodes when they need to be scaled out, scaling them back when they need to be scaled back, that's really achieving the elasticity that everybody's looking to get with cloud native and obviously with DevOps as well. So number 4, operations built for scale, built to scale. So I guess we had a couple points that we wanted to highlight here. One, thinking beyond just the DevOps tools automation, right? So really thinking about automating everything. And again, automating the full stack is one example. And then 2, beware of even minute inefficiencies at scale. This is, unruly costs can hinder your DevOps initiatives. And I guess just to kind of flesh that out a bit, Eva, do you want to just talk about some of the things you're seeing with customers, right? Where, resizing of containers, you think a container is so tiny and what could it possibly do? But at scale, it can really cause some issues.
Yeah, so there's scale considerations within, a set of services, and then just the challenges of being multi-tenant. I think that's, and Dan can speak to that about patterns of how you should build and run infrastructure, but being multi-tenant clusters, those are very good patterns, but it introduces additional levels of complexity that could actually slow down the scaling and adoption. So before another application team can onboard to the platform, someone's got to stop, do a spreadsheet exercise. Can I onboard this additional application? They should be in parallel asking the question, have the existing applications been optimized? Are there people using too much resources, or maybe allocating is probably the better word, allocating more than they're actually using? So I think if you look at CI/CD as a way to accelerate building applications, you should be looking at the ways to manage the running environment so that you can more quickly onboard these applications and get them onto the platform to get to the benefits of everything that these application teams have built, and then feed that back to the application team so they understand how are my services running in test, then production, were my assumptions correct, right? And then if software is making decisions, then people can focus on actually servicing the business.
Yep. So yeah, you've touched on both 2 and 3. Again, success brings challenges of rapidly scaling. Make sure you have a plan for growth. So there's a lot there. And then 4, this is a big one. Use solutions that are already built so you can focus on your unique business needs. We're here talking about DevOps, but specifically DevOps for the enterprise. So obviously got to think about scale. And I think that's a good transition here. Dan, if you want to talk about, let's talk about this platform that Red Hat offers.
Yeah, so that's a great segue. In fact, the last point was about you use solutions that are already built. So one of the things, Red Hat's the leading enterprise open source software company, right? We sort of built the business around open source development model. But what we find is a lot of people think, well, Kubernetes is an open source project. We have a bunch of smart guys in our company. We'll just take the Kubernetes open source upstream stuff and we'll build our own platform with it. The thing they don't realize is that what they're really taking on, what they really have to own after they do that, because there's always security patches coming out, there's always updates, especially in the open source projects. There's very frequent updates, and then there's also a bunch of ancillary projects and tools that you need in terms of service mesh and development tools and that kind of thing. So if someone wants to build an open source upstream version of Kubernetes, they're going to need to manage all that stuff on a daily basis, basically, and they're going to need to fix things when they break, and so they're going to own that. And so what we'd like to ask customers is that, so what if the guy that built that then leaves the company? Then what do you do? But anyway, the point is OpenShift is an enterprise application platform that's built on Kubernetes. And it's something we've been investing in for about 5 years now. And it is truly enterprise grade. It's on version 4.3. Recent studies have shown that it has about 44% market share for Kubernetes. We've got over 1,300 enterprise customers running on it, and it really is solid. But it's solid, but it's more than Kubernetes, right? It's we include the kind of core kind of upstream Kubernetes. It's a fully compliant Kubernetes platform. But then we layer on top of that things like developer services, development environment, tools for developers, CI/CD tools. We actually have an integrated development environment in a browser, so you can just work in your browser and do your development. That actually allows teams to collaborate on projects they're doing on OpenShift. And it's got cluster monitoring and cluster management services built into it that are above and beyond kind of core Kubernetes. We add to it the service mesh, Istio service mesh capabilities. Just a lot of functionality and capabilities that we layer on top in order to make it a real usable platform for enterprises, so that they can purchase, install, and spin up, and then give their developers access, and their developers can be off and running. And so we do all that with the OpenShift technology. Again, it is extensible, and we are, being an open source company, we're very open to collaborating and working with other partners, and so it's extensible. So we've made, extensions and APIs available for partners like Turbo to integrate with us and provide value add on top of OpenShift. And so that's what kind of the Turbonomic capabilities can do in terms of the performance and elasticity monitoring.
Yeah, and Dan, we're fortunate that in our customer base, we're seeing people, move to OpenShift for all those reasons. But the experience, I have to say, even with how we use OpenShift internally, that's a great experience. Before, migrating a cluster was a little bit of like, updating a cluster was a little bit like chewing nails and, hauling in hardware. And I literally went and pushed a button to not only deploy it, but to update it. And I have to say that over-the-air update was a great experience.
Yeah, exactly. In fact, if you go to the next slide, we can talk a little bit about kind of what we've done in terms of making life easier for the operations teams. So really improving improving operations both day one and day two. So the initial installation, as well as kind of the ongoing management of the platform. With OpenShift 4, we've really revamped the whole way it's architected and designed, and allow us to do this. So the installer now can actually automatically provision all the infrastructure it needs in terms of the VMs and hardware underneath. And it kind of, in OpenShift 4 includes CoreOS, which is RHEL CoreOS, Red Hat Enterprise Linux CoreOS, which is a version of Red Hat Enterprise Linux specifically designed for containers in OpenShift. And then once you've installed it, then you're deploying applications to it. It becomes very easy. It can run the same on-prem or in the cloud with the same experience. It's got a lot of security built in. One of the kind of key differentiators for OpenShift is, since we've built it, it runs on Red Hat Enterprise Linux, And Red Hat Enterprise Linux has been around for 25 years now. It's one of the most proven and hardened operating systems in the industry, and has a lot of security features built into it, such as SE Linux, Security Enhanced Linux. And so OpenShift runs on Red Hat Enterprise Linux with SE Linux turned on, which actually catches and prevents vulnerabilities. There was a container runtime vulnerability happened last February that impacted all container runtimes in the world, basically. But because OpenShift had SE Linux turned on, it didn't impact or hurt any of our customers. Just an example of some of the enterprise, history and strength that we bring to the table here. And then there, in terms of operating and running, we have a bunch of capabilities for doing the things like over-the-air updates and monitoring and alerting and vulnerability scanning. And then we bring in Turbonomic to add the application resource management and some of the kind of nifty stuff they can do with the container scaling and movement and that kind of thing.
Yeah, and we've thought about our deployment model as well, and we leverage an operator to deploy our mediation right into the cluster. And in fact, with eating our own dog food with our next generation microservice-based platform, we can deploy right into OpenShift as well. So we can be a platform within OpenShift managing your application resources of your containerized services. So it's a nice story.
Yeah, exactly. And I may not have talked about operators, but OpenShift operators and really Kubernetes operators are a way that you can install software on a Kubernetes or OpenShift environment, and that operator for that software will tell OpenShift exactly what to do with that software. So say it's a database, an operator for a database will tell OpenShift how to spin up that database, what kind of persistent storage it needs, how to manage it, how to shut it down when the container needs to go away. All that is sort of automatically taken care of using Kubernetes APIs for these operators. So it becomes a really elegant way to manage third-party software. It makes it super easy to plug that software into OpenShift. We also, by the way, we use that internally within OpenShift to do a lot of this automated management that I was talking about. But it helps our partners like Turbonomic to just make life easier in terms of getting their software into our ecosystem.
Yep, and then like the machine operator that actually allows for cluster scaling with just calling an API and spinning up another node. It works as described. It's great. So we like leveraging that.
Awesome.
Yeah, and actually, if you want to, speaking of leveraging that, going back to earlier where we were talking about Turbo's core value in terms of making resource decisions, being able to leverage that operator again to spin up or spin out nodes and back is really about getting that elasticity that we talked about.
Right. We just provide the brains to say, when do you need it based on the service demand, and does your infrastructure support the ability to even spin one up, right?
All right, so number 5, establish a business stakeholder feedback loop. So we just have a couple of quotes here, again, from this survey that we did earlier or last year. Buy-in from executive management first, buy-in from all employees, communications across the organization. Why are we doing this? What will the outcome look like? How will it benefit the company? How will it benefit you? So, this touches a little bit also on the collaboration, cultural buy-in side, but the second quote, have business buy-in and make them a part of the process, have the responsibility for providing expertise and funding, find out who the budgetary decision makers are, CFO, CEO, board members, and show how modernization can personally impact their jobs. And then demonstrating whether or not sustainable growth is possible on current architecture based off of current trends is a valuable lens with which to examine the necessity of modernization. And all of this really just comes down to, what are you doing DevOps for, right? It's about that throughput, it's about faster innovation, and it's really being driven by business needs. So you do need need that business stakeholder input and that collaboration there as well. So Dan, do you want to add anything here based on some of experience you've had?
Yeah, I would just add, and just to kind of reiterate what we said at the beginning, is that the cultural aspect of DevOps is probably the hardest thing you're going to have to do, right? The technology is there. There's lots of ways you can use automation technology and use platforms like OpenShift, but actually to get your organization to get their head wrapped around how DevOps works and what it's going to mean to them, and how to maybe perhaps even reorganize in order to align kind of with the model that DevOps needs for doing kind of full lifecycle deployments and stuff is challenging, right? And that's what we spend a lot of time talking to customers about culture and how cultural change really can help your bottom line, because it can help you get to this kind of digital transformation, if you will, for lack of a better term, but help you transform your business by using methodologies like DevOps and using technologies like containers and Kubernetes. But it all starts with kind of getting the cultural buy-in and getting the culture aligned to that. And that's can really be hard. We are, an open source company. We have a very open and collaborative culture at Red Hat. In fact, our CEO has written a book called The Open Organization. And so sometimes we even recommend that our customers kind of read that, because it'll get them thinking about how to be more open and more collaborative in your organization and in your internal business. Again, it's one of the tougher challenges when looking at DevOps. The technology part, in a way, can be the easy part.
Yeah. Right. Yeah, you shouldn't do it just because the cool kids are doing it. But even some of the successful OpenShift customers that we've had the pleasure to interact with, I think took a pragmatic approach. They aligned the right kind of executive or line of business kind of sponsorship, took their just one or two applications, made them super successful, leveraging the experience of companies like Red Hat, OpenShift. You don't have to go the journey alone, like you said, that because it's such an collaborative community behind it. It makes it, I hope, easier for people to think about being collaborative even inside of their own organization. But you got to get that successful sample application out there, and then that success breeds other lines of business or applications to come on board. And then before you know it, Dan, I don't know if this is your experience, but I've seen people go from, yeah, I want to modernize applications, I want to do Kubernetes because it's cool, I want to partner with OpenShift because I want the experience behind how to get there faster. And then it goes from that to becoming a mission critical platform where it's container first, almost like any line of business has to have a reason why they wouldn't modernize their applications.
Yep.
Great. So that with that, we're wrapping things up. Again, if you guys have any questions, please put them in the chat, and we're very happy to respond. We're also sharing some resources here, so you can learn more at openshift.com. A bunch of good resources there. Turbonomic is Red Hat certified, and we have a 30-day trial at our website, which you can check out. And then we just wanted to highlight a free tool, free forever tool that we recently launched called Lemur, and it's really for developers who, they can look at their microservices in the context of the application stack, which you kind of saw a little bit of earlier, and solving the problem of, before you put that service out into the wild, getting a sense of if there are any performance issues, is it to do with the code or the underlying infrastructure at that or the node layer? So we'd love for you to check that out, as well as the 30-day trial, whatever's more relevant for you. And I guess any last words, Eva, Dan?
Well, just a little plug on the Lemur thing. What we did was we, in the spirit of open source and open collaboration community, we saw that people were taking advantage of these open source tools in the observability pillar. And we recognized that individually they do some things, but what was missing was I could get resources from Grafana Prometheus, which OpenShift will actually bundle as part of their monitoring. I could actually get some tracing with something like Jaeger. I could get even some service-to-service metrics, especially if I'm looking at things like service mesh, and I think OpenShift even has, in OpenShift 4, there's an OpenShift service mesh. But what was missing is really the context. It's not so easy to jump from just one thing to another, but to have the context to go from a service to see the full, we call the supply chain. This is what we decided that we could bring to the community, was that visibility of that supply chain so that you can leverage observability, but with context.
Mm-hmm. And I guess, Charlene, do we have any questions?
Yeah, sure. Plenty of time for questions, guys. If you have one, please use your GoToWebinar control panel and submit your questions. We've gotten a couple in so far, so let's go ahead and dive right on in. First question, what is the difference between OpenShift and just vanilla Kubernetes?
Oh, great question.
Well, I guess I'll take that one. Yeah, so that's a good question, and it actually comes up quite frequently. So Kubernetes, actually, the history is kind of interesting. Google has, who's been, obviously one of the leading hyperscaler cloud providers. They've been running containers in their environment. In fact, their environment has been running on containers for years. And they had actually created internally this internal project called the Borg. If you're a Star Trek fan, you'll know that.
I like that.
Borg was this tool that managed all their containers and helped orchestrate them and scale them up and down and that kind of stuff. And then they realized that might be useful for other people because containers were becoming super popular in the industry with Docker and everything. And so they open sourced the Borg as Kubernetes. And that was about 5 years ago, I believe, if I'm not mistaken, or 6. And so the Kubernetes project was released. It became eventually part of the Cloud Native Computing Foundation as a top tier project, and so it's an open source project that's out there. It has a ton of people working on it from companies across the world contributing to it, but it is an open source project, right? And that means that it's fairly volatile, right? It moves very quickly in terms of changes to it. They have probably daily or nightly releases and probably weekly builds as well, and so. The difference is that is something that's very fast-moving, fast-paced, and changing all the time. It provides the core Kubernetes functionality, which is container orchestration. And OpenShift takes that upstream project, and what we do is we actually test and beat on it for a couple of months before we release it. So we actually do a lot of testing and bug fixes and security fixes. We push those back to the upstream, of course, but when we release an OpenShift version, it's going to be a kind of hardened version of Kubernetes. Plus, it has all the other stuff that I mentioned on top, the language runtimes, the development environment, the CI/CD tooling with Jenkins and Tecton, the service mesh with Istio and Jaeger and Kiali to help manage that. All this stuff is bundled in to make it actually a fully functional application development platform that you can build, and your developers can build applications and deploy them, and your operations team can manage very easily. So it's OpenShift, sort of like Kubernetes plus. It contains the standard kind of certified Kubernetes distribution internally, but it adds a lot to it. Value-adding capabilities on top of Kubernetes. So that's kind of fundamentally the difference.
Okay, great. Our next question, what about DevSecOps and API container security from hackers? I'm not quite sure what the context is there.
Yeah, so I mean, I can touch on that, and security is certainly a key consideration, right, for any organization that's building applications. We're hearing about those unfortunate news articles all the time of like a breach exposing millions of customer credit card records or whatever. And so anybody that's building applications in a big enterprise needs to be very conscious of security. You mentioned DevSecOps, so that's kind of one of the latest buzzwords. DevOps has been around for a while, but now people are rightly so saying, no, we need to get the security team involved in this process too, right? We need to get security looking at things very early on. When developers are checking in code, let's run security scan software on it. Let's do that very early. And so the security team becomes yet another member in kind of the DevOps core team, right, with developers and operations, and security, and testing. And so DevOps transforms into the DevSecOps lifecycle, right? Again, there are things you can do in containers. to make them more secure. And that's like, for example, running with the security enhanced Linux turned on in the container runtime that you're running underneath, right, or the container host. And so that provides kind of this additional level of security. So we certainly think, realize it's very important. We've been, working with security for 20 years or so, and that's how Linux has become one of the leading operating systems in the industry, and RHEL the leading kind of paid Linux version, because we focused on making sure security is important and top of mind, and we work very hard on that.
Yeah, and as a partner, Red Hat, we actually leverage the Red Hat Container Catalog, where we have our solution available, but it provides this added level of maybe confidence for someone who wants to actually deploy a third-party solution. It's one thing to have, you should have definitely, like you said, security practices and securing your own services, but then there's that risk of I'm using a third-party software, right? And so we leverage the Red Hat Container Catalog as there's some built-in security scans. We, of course, leverage RHEL and UBI version 8 as part of building our container images. So I think even there's some responsibility for third-party vendors too, as it's a smart idea to containerize your own product and leverage the benefits of an OpenShift platform, but I think that's how we take some responsibility in that.
Yeah, and we appreciate that. The container catalog is something where when Red Hat's working with a partner like Turbonomic, they build a container, with our recommendations and guidance, and then we actually certify that container. So we actually do testing on the container itself before it goes into the catalog. So customers can, just like RHEL had certified ISVs back in the day, we now have a certified containers, and those are the ones that are in the catalog.
All right. Great. Okay, next question. Sun Micro Solaris VM can scale memory allocation dynamic to VM. Can OpenShift and Turbonomic detect and allocate memory per pod basis?
In terms of, this is actually an interesting question, because what I will say is that when Turbonomic looks at the fluctuating demand on a cluster, one of the concepts that we adhere to is ephemeral infrastructure. So if more memory is needed, rather than adding it to an existing node to spin up another node, again, just from the workflow perspective, things like the machine operator make it a very easy thing. Because I don't know if Red Hat has some of this in the plans or if the Kubernetes upstream community, but there is some downtime, I think, to reconfigure an existing node. And the responsibility then is that you've got to drain that node, you've got to accommodate those, or you should accommodate those pods on other nodes. But if you really are running out of space in the cluster and need to allocate more resources, you probably don't have that luxury, right? So I know from a Turbonomic perspective, we have flexible analyses. We can help you understand sizing, scaling, placement decisions. But I'd like your thoughts, Dan, too, about some best practices around allocation of more resources.
Yeah, it's an interesting question. We don't actually see a lot of Sun Micro Solaris VMs, used in the context. OpenShift is built on Linux container technology, and so we're running in that environment. So I don't have a lot of data points in terms of being able to answer the question about the VMs, the Sun VMs, scaling the memory dynamically and how we would handle that. I don't think it'd be a problem, but that'd be something we would probably need to do a little research and get back to the customer with.
Perfect. So then let's take a look at one more question. I think we have time for one or two more questions here. Does OpenShift provide built-in monitoring, or do we need to run the respective services on OpenShift?
It does have some monitoring built in for sort of monitoring the platform itself, and you can see the pods in the containers that are out there running. Some kind of baseline metrics on those, but it's enough for an operations guy to get a sense of kind of what's going on in the environment. But our focus hasn't been on kind of the full detailed application performance management capabilities and resource management capabilities that a partner like Turbonomic would provide.
Okay. All right, great. Okay, next question here. Turbonomic as application resource management, what are the key functions it performs?
Okay, so I would say in summary, what we provide is first full stack visibility, that you can go from your services to your containers, pods, down through the nodes into the underlying infrastructure, into cost of running in the clouds and the zones and the regions that you're in, related storage, or if you're on-prem, the cluster resources, related fabric networks. I mean, we really we've been around for over 8 years, and we've got quite the inventory of mediation that we can build out what we call this full stack supply chain. And that's important to kind of look at trends and look at some of that monitoring data, but we actually exist to turn monitoring data into actions, and into actions that can be executed. So our value in containerized services is that we manage the trade-offs of performance and efficiency to make application resource decisions continuously, 24/7, 365 days a year, to mitigate performance risks due to resource starvation while trying to optimize the way that the entire stack runs. So we take data and turn it into actions. I recommend that you go to turbonomic.com. We've got some great visuals there on the actions. And I think, again, the takeaway is, if you're just monitoring something and setting thresholds, you just got a very myopic view of what you need to do. A Turbonomic action takes into account the relationship of the demand for resources, available supply, and constraints in the environment to drive actionable decisions.
And actually, on our website, if you, it's one of the product pages, you can see all of our integrations. And we've really focused on OpenShift and Kubernetes here, but we, as Eva mentioned, have been around for quite a while. So there's like 70 plus integrations there, and it's whatever you have in your environment, taking that data that's already being exposed, software makes those resource decisions automatically, so you get that continuous performance and elasticity, as we were talking about before.
All right, great. All right, so we're about 3 minutes to the top of the hour, so I'm going to go ahead and close out the question and answer period. If we did not get to your question, please know that the folks on today's webinar will be receiving a copy of all of the questions that come in. So I'm sure they'll be more than happy to follow up with you offline, either them or somebody from their organization. So fret not, we'll get your question answered. Okay, before we close things out, I do want to do the drawing for the 3 $50 Amazon gift cards. So without further ado, we'll go ahead and do that. Our winners today are Kelly K. Congratulations, Kelly. Daniel S. Congratulations, Daniel. And Chris B. Today's webinar via email to get those gift cards to you. Also, want to remind the audience real quick that today's event has been recorded. So if you missed any or all of today's event, or if you just want to listen to it again, that's totally cool. You'll be able to do so later on. We will be sending out an email that contains a link to access the webinar on demand. The webinar is actually also going to be living on the devops.com website, so you can always find it there. You can just go to devops.com/webinar and look in the on-demand section, and it should be right there waiting for you. Let's see what else. Want to thank today's speakers for giving such a great presentation. Eva, Asena, and Dan, thank you all so much for your time and great presentation. So thanks again.
Thank you guys, and thanks to the audience for giving us the time.
Yes, thank you to the audience for joining me today. This is Charlene O'Hanlon, and I'm now signing off. Have a great day, everybody.
Bye, guys.